Okay, so for this week is Laplace transform. We will enter the Laplace transform, and for this week we will learn two topics. Okay, the first one is introduction, and also the second one is properties. Okay, so we start first with the introduction. Okay, we start first with introduction. So introduction here is okay, how we write the Laplace transform lah. Okay, L, and then okay, we have a curly bracket here, and then inside the curly bracket we have ft. So ft is a function lah, of course. Ft is a function, and this is what we call the Laplace transform for the function. So when we get this type or this form, Laplace transform for this function. So this is how we read it. Okay, kita baca macam tu lah. This is the Laplace transform for this function. Or sometimes some textbook or some notes just write Fs. So Fs, capital F here, is represent Laplace transform also. Okay, so maksudnya kat sini ada dua cara lah tulis, satu L function, satu lagi Fs. So actually is Laplace transform. Okay, by using introduction. Okay, this is introduction. So this is how we find the Laplace transform ataupun definition lah. Okay, the definition of Laplace transform. Okay, so this is how we find Laplace transform for a certain function. Okay, function kat sini dia boleh berubah lah. It depend on the question. Maybe sin t, cos t, t square, t cube, exponential. Okay, terpulang. But this is how we write, or this is how the definition of Laplace transform. Okay, Laplace transform. So how to find the Laplace transform? Okay, this is the way. Okay, by using integration. Okay, so E negative st is already fixed. Okay, tak perlu ubah, memang fixed. 0 until infinity also fixed. Yang berubah, okay, the changes here is on ft. Okay, here this one will follow your ft here lah. Kalau ft kat sini, if here is sin t, so that's mean here is sin t. Okay, alright. Okay, so this is, if the question asks you what's the definition of Laplace transform, okay, you just write this. Okay, this is the definition of Laplace transform. Okay, so now, okay, I will show you example on how to solve it. Okay, to find the Laplace transform. Right. So, okay, let's say we have your ft is equal to a. Okay, let's say lah. Okay, a is a constant. So a can be any number. Okay, a is a constant. It can be 5, it can 100, it can be 1000, it can be negative. Okay, doesn't matter, any number as long as it's a constant. So how to find the Laplace transform for constant? So we write first here. Okay, because this is your Laplace, your function is a, right? So you just write a inside here. So then 0 infinity e negative st. So this is already fixed. Okay, kekal, tak ada perubahan. It's already fixed, maintain. The changes here is on your ft here. So your ft now is become a lah. You just copy what we have here. Okay, and then integrate with respect to dt. So we know that integration of constant, we still get constant. I mean, no, integration of constant, it doesn't affect. So why not we just take it, this a, outside from the integrand, because it's just a constant. Okay, so I take out a, I put it here. Okay, so inside here I left with only exponential negative st. So exponential is not a constant. Okay, class, exponential is not a constant. Exponential is a function, non-linear function. Okay, and then they have t here, so you cannot take out exponential outside here. Okay, because if exponential power 1, yes, you can take out. You can bring exponential power 1 outside here, because exponential is a number, is a constant 2.718 something. But now your e now they have a power of t. Okay, so means that you cannot take out, because t is your variable that you want to integrate here. Okay, so now how to integrate exponential? Okay, I don't want to explain in depth about that one, because supposedly you should know already how to integrate exponential. Okay, I just write the final answer here. So integrate exponential, you will get e negative st over negative s. Okay, and then you have a value here, right? 0 infinity. Okay, so what we do next is just substitute these two value 0 and infinity into t. Okay, into t. So just substitute. So negative s infinity over negative s, then minus e negative s 0 negative s. Okay. So here you can see that e power of k negative s, even though they have a negative s here, but when it comes to multiplication between infinity is a big number. So maksudnya kalau number apa-apa pun, let's say lah s ni, assume lah s ni 2, for example s is 2. When 2 times with infinity, okay, let's say your infinity here is a million number, million. So million times with 2 is still considered million, kan? Maksudnya small number times with a big number, we still get a big number. So we just assume that this is all the infinity. So exponential power of a big number or power of infinity, we will get 1. Sorry, we will get 0. Okay, we will get 0. Okay, I repeat, exponential when it's come to power with infinity, a big number, it will be get 0. Okay, so when the denominator 0, of course lah, semua ni kosong lah. Okay, all are zeros. Okay, now the second one, s times 0 will be get 0. So e power of 0 we will get 1. Okay, so this is 1. Okay, 1 over negative s. Okay, I continue it here. Okay, okay. Okay, I just want to fully utilize lah the space here. Okay, so a here is 0 and here is negative. Okay, 0 minus 1 over s. This is how we write it. Okay, this is how we write. Okay, minus here minus and s also negative. Okay, jangan lupa pula sini ada negatif, don't forget to write negative here. So ni ada negative. So negative so become plus lah. So a 0 plus 1 over s. Therefore the answer will be a over s. Okay, a over s. Okay, a times with 1 over s, yeah, of course lah, 1 over s, a over s. So this is the answer. Maksudnya, okay, what the Laplace transform for ft equal to a? So this is the answer. Okay, the Laplace transform for ft equal to a is a over s. Okay, now let's say lah, this question, the marks is 10 marks, so it's logic lah. Okay, logic 10 marks. But if, okay, I give you another one example. Let's say lah, if your ft is equal to 5, okay, 5, okay, because a can be any number, right? So let's say I choose 5. Okay, find out the Laplace transform for 5. What's the answer? And the marks is only 1 mark. Okay, class, just now I show you how to do or how to find the Laplace transform for a constant. And the way, let's say lah, the marks is 5, the mark, yeah, 5 or 8 or 10 lah. It depends lah on how long. Okay, but now it's the same question. It's the same question actually, because it's the same function. I just substitute a with a number. Okay, Laplace transform of 5 and the marks is only 1 mark. Logically, of course lah, mestilah you takkan tulis ataupun you takkan calculate macam ni, betul tak? I mean, maksudnya there must be have a direct forward answer. Maksudnya no need to use all this. Is it? Yes, betul. If the answer, if you can see that the mark is only 1, and actually you already done it before, which is you show that the Laplace transform for constant just now a, the answer is a over s. So means that if your a now is 5, so that means the final answer is 5 over s. Okay, get it what I mean? Okay, maksudnya macam ni, if your ft is numbers, okay, you just can use directly this one. You can use directly this one. it depends on the marks lah. Kalau marks tu banyak, means that you need to show all this. If the marks is only 1 or 2, maybe you just substitute the value here, okay? Because this one is already fixed. A over S is already fixed, and it can apply for all constant. So if your constant is 100, so that means it will be 100 over S. Okay? If the constant is -1, -1 over S. Okay? So I hope that you get what I mean here. Okay? So they have two way. Maksudnya, of course, the first way is by using the definition. Okay, the derivation means you need to integrate, you need to show your steps. And another one is by using table. Later on, I will show you the table. Okay, I will show you the table. So actually, the table is much easier. Not much easier. Memang you akan guna table pun. Okay, you will use table to get the answer actually. But yeah, as a starting, because we just enter this topic, so you should know lah juga how to get it by using definition. Okay, so in the next video, I will show you table first, then we will use the table to answer the Laplace transform. Okay.